All right, you guys, I hope you're working hard and making these days count. Everything you guys learn from this will help you on the AP exam, so please be putting in your best effort. Number 31. So we've got binomial on this one. He either reaches a just decision or he does not. And we want 2 out of the 3 to reach a just decision. So binomial CDF on your calculator. N is 3, probability of success is 80%, and we want from 2 to 3. That gives us this. So if you wanted to check all these, you could. This also comes from 2 of those formulas on your sheet where you're adding the probability of getting either 3 or 2. All right, so regression on the slope. So remember that this whole second line here is slope, and this is the slope, and this is the standard error of the slope. So here we have our slope, and here we have our standard error. All of these are more like your formula for means. And then, of course, this comes from inverse t. We use inverse t for slope. We want 99% confidence, so that's 0.005 for our area. And remember, degrees of freedom is always n minus 2 for the slope, so that gives you 6, and that gives you the 3.707. All right, so what's wrong with all of these? This first one, probably high schoolers aren't going to want to talk to some random PTA person, so I would call that response bias. Response bias is when you just have a systematic wrong errors or wrong answers. This next one, we've got people calling in. So anyone who cares is going to call in. So this is called voluntary response bias. And this last one, I would say, is under coverage. So they're leaving out anybody who doesn't read their journal. All right. So the correct answer is B. They all have errors that can lead to strong bias. So none of these talk about stratification. And also sampling error is just normal. There's always sampling error involved. So don't let that confuse you. Okay, so you have to know the formula for margin of errors, okay? So if you're doing means, the formula looks like this. All right, that's for means. If you were doing proportions, it's still Z star, but our formula for proportions is P times 1 minus P over N, and we want to be within a certain margin of error. I see these on almost every test, you guys, so you have to know these 2 formulas. So first we start with the 95% confidence interval. We want to be within 0.5 days. We have our N, and that allows us to solve for sigma. So 95%, we can do inverse norm, 0.025 for our area, mean of 0, standard deviation of 1 to get this 1.96. Okay. We're looking for sigma, and then we have square root of 100, and you can find sigma by solving. All right. Then we plug it into another margin of error formula for the second part. So how many records should be looked at for another 95% confidence level? Now we want to be within 0.25 days, and we're trying to find N this time. Okay. So remember, when you plug this into your calculator, try not to round. So always grab the past answer. So I would divide by 1.96, multiply by the square root of N, then divide by the 0.25, and we get 400 for our sample size. All right, this one was kind of a toughie. So you either win, lose, or draw. So that takes out C, D, and E because all of these are talking about binomial, and binomial you could win or lose, right? It's success or failure. So you can't have 3 outcomes. This one's also talking about binomial. It doesn't specifically say, but that's how we calculate mean and standard deviation for binomial. So we got to look at A and B. It's easiest if you make kind of a table. So you're either going to win, lose, or draw. You win 80% of the time, you lose 5% of the time, which means you draw 15% of the time. And they give you the respective points, 1 point for a win, half point for a draw, 0 points for a loss. Okay, read carefully because it says what is true about the sampling distribution X of the points scored in 2 independent games. So like we could lose twice. And if you lose twice, that's a 0.05 times a 0.05 probability, which is this. And that means we'd score 0 points. So I already can see that this is an option. All right. We could also lose and then draw. And we could also go in the other order, draw and then lose. So if I lose and then draw, it's 0.05 times 0.15, which is 0.0075. But again, we could do that in the other order, so I double it to get 0.015. That's that probability. And again, this gives me a half point if I lose and then I draw in either order. So that would be the next one. Okay, all the way up to a max of 2 points, which we could get by doing 0.8 times 0.8, which gives us this 0.64. So it's B, every combination of all 3 of these. Okay. All right, 36. I was tempted to put E on this one, but it is A. So the problem with E, if the p-value is less than the significance level, then the null hypothesis is proved false. We never say that, right? If the p-value is less than alpha, we do reject the null, but it's never actually proved false. All right. The p-value is always a conditional probability because it's given that the null is true. That's the start of that sentence for P that you need to have memorized. And that means it's conditional. So I'm assuming one thing. If it's true, then it's the probability of getting a sample as higher, higher, or as lower, lower as the sample that we got. Okay. P-value is chosen before the experiment's conducted. No way. We always calculate it. All right. A p-value is based on a specific test statistic and should not be used in a two-sided test. We always get a p-value for a one-sided or a two-sided test, so that's not true. And we definitely use them for either t or z distributions. It doesn't matter. Okay, so it is A. 37. All right, so do you know your definition of a type 2 error? So you want to memorize that type 2 means fail to reject the null when we should have. So if I failed to reject the null, my math told me that this was true, but in reality, this was true. So the alternate is actually true. So what happens is we continued to produce the wrong size ball bearings because we thought we were good, but in reality we weren't. So we're producing the wrong size. So C is correct for 37. All right, I thought 38 was a little bit tricky as well, but we're just interpreting the confidence interval. Actually, not interpreting, we're just giving the conclusion. So think about what your concluding statement should say at the end of a confidence interval. And it's close to D, but it's not. So it says we are 95% confident. And it should say that the difference between the mean cholesterol level of Lipitor and niacin is between 18 and 24. This just says that it will outperform. That's not how you would interpret the conclusion for that confidence interval. So you should go with E on this one, none of the above. Remember, it's always bad to say this. There's a probability of this happening. That's not true. That's never how you do a confidence level. It's always after repeated confidence intervals, the chances of the true mean falling within that confidence level. All right, you should definitely be able to get 39. How many months is the median below 4 hours? So you got to find the median here, here, and here. Those 3 months have a median below 4 hours, so the answer is C. You should also be able to get this one right. So this says we want to be able to meet the demand at least 90% of the time. So you find 90% and you scroll down this way, and that would mean you need 20 rooms or berths. All right, so it is D. Okay. So the first one, what is the shape of the distribution? You want to look at the number of points that you have. You have a ton of points right here, lots of points, and then a lot fewer points after that. So that means it's skewed right because there's a lot of points here and fewer points here. Okay, what is the 95th percentile of the data? And explain what that would mean. So this one, you kind of have to think a little bit, but there is a random sample of 100 students, and percentile means that you scored better than 95% of the students. So if you scored better than 95%, you can count down 1, 2, 3, 4. Here's that 5th student, and scroll over to see kind of what that GPA would be. So this student was better than 95% of the students. And so that's about a 3.4 or 3.5 GPA. All right, part C is in a normal distribution with the mean and standard deviation of this data, what is the 95th percentile? So this line right here represents the normal distribution. And we can find what z-score goes with 95% by doing inverse normal. So if you do inverse norm, area 0.95, mean of 0, standard deviation of 1, you get 1.645 for your z-score. So if you go to 1.645-ish on this graph, let's say that's about here, and you go to the normal line, because I want to know where it is if this was normal. That's about a 3.2 GPA. All right. So number 4, you want to be able to do a confidence interval. A lot of the number 4 questions that I see are a significance test or a confidence interval. So hopefully you guys are really good at these. So part A, 95% confidence interval for the difference in mean cumulative NO2 exposure. So we start with our state. We wish to estimate the true mean difference in NO2 between drill and blast workers and concrete workers with 95% confidence. And then define your mu1 and mu2. So my mu1 is the true mean NO2 exposure in drill and blast workers. N2 is the true mean NO2 exposure in concrete workers. So we've got our plan. So this is a 2-sample T interval for mu1 minus mu2. Remember, we're doing an interval. We've got 2 samples, and T's always go with means. So random, we have independent random samples. So don't forget to add that word, independent random samples. For your 10% condition, we just look at N and times by 10. So we need at least 1,150 drill and blast workers and at least 690 concrete workers in 2004. All right, large counts, we're good to go. For means, it's always greater than or equal to 30, and both of our sample sizes are greater than or equal to 30, so we have large counts. All right, so this is our statistic, plus or minus our critical value times the standard deviation of the statistic. So we're going to subtract, and I am going to subtract 4.1 minus 4.8, so drill and blast minus concrete. Plus or minus, we will find T star separately, and then we're going to multiply by this little formula, which is on the yellow sheet. So it's your standard deviation squared over n plus your second standard deviation squared over n. Okay, it's easiest to calculate this first and then plug in what you did for your degrees of freedom to get your T star, because your calculator will find the most accurate degrees of freedom. So you want to go to menu, statistics, confidence intervals. These first 4 are all for means. And again, I'm doing a 2-sample, and we almost always use T unless we know the population standard deviations, which we don't. And for this one, we have the statistics, not the data. And I'm going to plug in my X1, which was 4.1. And my standard deviation was 1.8 for the first one. My sample size was 115. Second one, mean of 69. Standard deviation, nope. mean of 4.8, standard deviation of 2.4, and sample size of 69. You don't change your pooled or your not pooled. You leave that however it says. And our confidence interval is 95%, so we're going to leave that. All right, so we've got our answer here. So it's going to be between negative 1.362 and negative 0.038. Okay. This is really important. You have to write down your degrees of freedom. So I'm going to use 113.9 for my degrees of freedom. So I'm just showing how my inverse t, how I would have calculated that. If nothing else, you always write your degrees of freedom and then your answer. Okay, and then our concluding statement, of course, we are 95% confident that the true mean difference in NO2 exposure for drill and blast workers and concrete workers is between negative 1.362 and negative 0.038 parts per million per year. All right. Part B, so is there evidence of a difference? What you want to look at is is the entire interval above or below zero? And yes, the entire thing is below zero, so there is definitely evidence of a difference at the 5% significance level, since we did a 95% confidence interval. And part C, so it says both data sets were actually skewed. Does this invalidate your analysis? So if the true data was actually skewed, it really doesn't matter because we've got the central limit theorem that applies. And so we're taking large enough samples that our sampling distribution will be normal. All right, so the CLT applies and we're good to go because we have greater than or equal to 30.